Let's take a look at 2002 Form B, Problem 6. And before we get started, just a couple of comments for you. One thing that causes students frustration with problems like this at first is not really the lack of ideas. It's that when you see these problems, you have, in a way, too many ideas as to what you could do with everything. So I do think, though, that after we make it through probably this review packet, you will start being able to kind of diagnose each problem and look for the most elegant way to do a problem. And that is something that just takes some time and practice, but you will get there. Another comment, I know that some of you have expressed some frustration when things are given in sigma notation. But please remember, if in doubt, expand it out. And on this problem, you'll see me do that just a little bit to the point where it should just kind of relax your mind as to what they are saying with the sigma notation. Okay, so enough general comments there. Let's go ahead and get started. It says the Maclaurin series for natural log of the quantity 1 over 1 minus x is the sum as n goes from 1 to infinity of x to the n over n with an interval of convergence from -1 to 1, including the -1. Okay, so the first thing that I would like to do is just take a minute to process what they just said. And this does look a lot like me just copying it down, but sometimes it really helps. So they said that the natural log of 1 over 1 minus x is exactly the same as the sum as n goes from 1 to infinity of x to the n over n. And here's a moment for you to go ahead and just expand it out and just kind of look at, like, what are they saying here? So if n is 1, that would give us x. If n is 2, if n is 3, and so on. So, this is what they're saying. And you are welcome to do this problem in the expanded out version. I am not going to, because it's a lot more writing for this problem. And I think you'll see that leaving things in sigma notation is going to work out just fine for this one. Now, they're not saying that this equal sign right here is true for all x values. They're just saying that it's true. Those two things will be equal for x values that are in this interval right here. Okay, so now let's look at what they're asking for part A. Find the Maclaurin series for natural log of the quantity 1 over 1 plus 3x and determine the interval of convergence. Okay, so the first thing that I'm pretty sure everybody noticed is how much this expression looks like the given expression. And we are going to take advantage of that. So first thing I would point out is that the natural log of 1 over 1 plus 3x is exactly the same as, and I'm just going to try to make it look a little more like this given expression. So I'm going to rewrite it as the natural log of 1 over 1. And you can see here they're subtracting something. So what would we have to subtract to be adding 3x? We would need to subtract the opposite. Okay, so first I'm just going to point that out. Then if I look at this expression and this one, what would I have to do to this expression to make it be this one? And the answer is simply substitute -3x in place of all of the x's. So they said to come up with the Maclaurin series, so I'm just going to use that move over here. So I could take this x out, replace it with -3x. I'd have the expression that I'm trying to find a polynomial for, and I'm just going to do that right here in the sigma notation. You also could do it on the expanded out version. It's just a little more writing. So I would say that this would equal the sum as n goes from 1 to infinity of, instead of x, we're going to write -3x. Just like that. And that's it for the Maclaurin series for that expression. And I'm just going to go ahead and bring this little prompt down so it's nice and closely related. Now they also want us to determine the interval of convergence. And boy, oh boy, are there so many ways that you can find an interval of convergence. You could enforce the condition of convergence of the ratio test. You could do all sorts of fun things. But let's let's find a nice elegant solution. How did I just get this, this Maclaurin series? I simply took x out and replaced it with negative 3x. How could I find, what's a quick way to find the interval of convergence? I could take the interval of convergence on the original one and replace x with negative 3x, and that is what I'm going to demonstrate here. So this would be true for, take that x, replace it with negative 3x. There you go, x values that satisfy this situation. So let's just isolate x, little algebra 1, divide everything by negative 3. Please remember, dividing or multiplying inequalities by negative numbers reverses the direction of the inequality. There we go. And so this would be your interval of convergence. So Maclaurin series, interval of convergence. All right. Okay, part B. Find the value of the sum as n goes from 1 to infinity of negative 1 to the n over n. Very similar to the last part, you look for what's been given that is very similar to this expression. And so for me, this sigma notation is so similar to this piece right here. And what's the difference? They took x out, and what did they replace it with? They replaced it with negative 1. So if I go back up here to where I kind of digested what they were saying, these two expressions are supposed to be equal to each other as long as you're using x values that are in this interval. So what x value are they using? They're using negative 1. Is it in this interval? Yes, that means that these two expressions should equal each other. So what would that mean? That would mean the sum as n goes from 1 to infinity of negative 1 to the n over n would be exactly this side, just with x replaced with negative 1. There we go. And then simplify it, or not, because they kind of don't care. So you could say that's equal to the natural log of 1/2, and you'd have it. And that's it for part B. All right, part C. Give a value of p such that the sum as n goes from 1 to infinity of negative 1 to the n over n to the p converges, but the sum as n goes from 1 to infinity of 1 over n to the 2p diverges. Give reasons why your p value is correct. So for this one, my mind kind of started working on this one and what p value would make this diverge. And so I kind of looked for a p-value that would be on like a threshold of divergence. And so I decided that if I could get this to be just 1 over n, then I'd have the harmonic or a divergent p-series either way. So what p-value would make that exponent there be 1? And I decided to go with p equaling 1/2. And then before I got writing, I decided to come over here. Okay, well, what would happen if p was a 1/2 here? I'd have negative 1 to the n over basically the square root of n. And then you could think through what does it take for something to be a convergent alternating series, and you'd find out that if p is 1/2, this would be a convergent alternating series. Then it's just a matter of writing that down. So if p is 1/2, then the sum as n goes from 1 to infinity of 1 over n to the 2p would be the sum as n goes from 1 to infinity of 1 over n, and that is a divergent p-series. But the sum as n goes from 1 to infinity of negative 1 to the n over n to the p would be the sum as n goes from 1 to infinity of negative 1 to the n over n to the 1/2, which is a convergent alternating series. There we go. And that's all it takes. You don't have to go through the details of showing that the non-alternating part, which was 1 over square root of n, goes to 0, decreases in value, and is always positive. That's something that you should check in your head, however, before you make the claim like this. But this is all they're looking for an explanation. Okay, moving on to part D. Part D says, give a value of p such that the sum as n goes from 1 to infinity of 1 over n to the p diverges, but the sum as n goes from 1 to infinity of 1 over n to the 2p converges. Give reasons why your value of p is correct. And so for me, this was a bit repetitive. I was a little surprised that they tested it this way on this one. But I just decided, okay, well, let's see what happens if p is 1, because that's kind of the reason I go for p equals 1 is because that's on a threshold of divergence. And so it maybe would be something that would kind of affect the other one in a different way. So let's see, what if p was a 1? Then this would diverge. And then if p was a 1 over here, then you'd have 1 over n squared, which is a convergence. So there you go. And then the way I wrote it up was very similar to the way I wrote my answer for part C. So the sum as n goes from 1 to infinity of 1 over n to the p would become this, which is divergent p series, just like above, but the sum as n goes from 1 to infinity of 1 over n to the 2p would become the sum as n goes from 1 to infinity of 1 over n squared, which is a convergent p series. There we go. All right, my friends, I hope this information is helpful to you. Have a great day.